we'll go full screen. So you guys did a good job coming up with a bunch of the things about exponentials for me. So exponential functions are going to be ones that have a variable in the exponent. So we can have things like y equals 5 to the x. The domain of these has to be all real numbers. So it's going to have to be something that works for every x, positives, negatives, fractions, rational, irrational, in order to be an exponential function. So I could have y equals 5 to the x. I could have y equals a half to the x. I do have some restrictions, though. First one, the base cannot be negative. Because what would happen if I had something like -2 to the x? If all real numbers have to work for this, if it has to be defined for all real numbers, a half is a real number. But if I tried to say -2 to the 1/2, that's not going to give me a real number. So that's why I cannot have any negative numbers for the bases. I also cannot have the base be equal to 1. And the reason for that is it's too boring. If I did y equals 1 to the x, no matter what x is, I'd have y equals 1. So I'd really have the horizontal line y equals 1. It would not fit the pattern that you were just describing to me of shooting up real high if it is growth, or starting high and then decreasing if it's decay. So it would not fit the pattern. So 1 does not work. It also cannot be 0, in part because 0 is also boring. 0 to something would be 0 as long as x is positive. But if it were negative, it would be undefined. Because then I'd have y equals 0 to the -1, so 1 over 0. So those don't work. So the base can't be negative. It can't be 0. So what that means is the base must be positive, but it cannot be 1. Summarizing what we were talking about, we have growth when we have one that starts out near the negative x-axis and then shoots up. And we have decay if it starts out up high, comes down, and then approaches the positive x-axis. What's going to make the difference is whether the base is bigger than 1. Remember, it's got to be positive, can't be 1. If it's bigger than 1, it's going to be growth. If it's between 0 and 1, so if we have a base that's a fraction, then it's going to be decay. So far, so good. Tell me about the y-intercepts on these graphs. Can you tell me what the coordinates are? If it's a y-intercept, what is the x-coordinate of that point? What's the first coordinate of that point? 0. And so if we know what x is and we want y, we're going to plug into our formula. So let's suppose this was 2 to the x. So if x is 0, what's y? 1. So the y-intercept, unless we have had a shift, is 0, 1. Same thing true if it's decay. If x is 0, what's y? So unless we have shifted that function, it's always going to have a y-intercept of 1. Or multiplied the whole thing by something. So let's go through a couple of graphs of how we do these. So I require you to plot all lattice points, which means everything that has integers for both coordinates. You don't have to worry about the ones that have fractions in there. So do we know the y-intercept? We know the y-intercept 0, 1. And we could have done that again with a table. If x is 0, y is 1. And is this going to be growth or decay? It's going to be growth. So that means in this first quadrant, it's going to be shooting up higher and higher. Those are the ones I'm interested in plotting. So if x is 1, plug that in. What's y going to be? Everybody. So we're going to plot the point 1, 5. If x is 2, what's y? 5 squared would be 25. Now that's going to be way up here somewhere off my grid. So in this first quadrant, I'm going to go from my y-intercept through that 1, 5. And then I have to make sure that I do not actually cross that line y equals 2 before I leave the grid. Because I don't have like 2, 8. It's got to be heading up, pointing up towards 225. When we draw this branch, we're not going to worry about plotting points. We're just simply going to draw something getting closer and closer to that x-axis. We could, if we wanted to, plug in like a -1 and have a fifth, but you see how that's quickly going to be impossible to really plot in there. We're going to label those lattice points, and we're done. One more of those. So growth or decay this time? Decay. Y-intercept. So 0, 1. Since it's decay, we're interested in points in the second quadrant. So we need negative x's to plug in. So if x is -1, this is a third to the -1, which is, so we plot -1, 3. If x is -2, what do we have? What? We're going to have 1/3 to the -2, which is, shout it out for me, 9. And then by -3, we're going to be off the grid. So we draw this in coming down through these points. And make sure I've got that lattice point labeled. And there's our graph. So that stuff's easy enough, right?